Okay, so we're going to be talking about free fall. Okay, so free fall, when we talk about free fall, we need to ask ourselves, of course, everybody knows, semua orang tahu lah apa maksud jatuh. In Malay, it's called jatuh bebas. Okay, so the question is, the question that we need to ask is when someone is falling freely, bila ada orang yang jatuh bebas kan, okay, bebas dari apa sebenarnya? Okay, that's the question that we need to ask. In order for us to understand the real concept of free fall, kita mesti faham what are we free from. Okay, so for example, if I'm going to drop this doll, yeah, she feels very, okay, so if I'm going to drop this doll, okay, she's obviously going to fall lah. Okay, so, yeah, she's being very tortured now. So, you know, if I'm going to drop this doll, she's going to fall. Okay, if I let go of my hand, yeah, if I let go of the hand, she's going to fall. Okay, say hi, Hope, hi. Okay, she's going to fall. Okay, if I let go of my hand, okay, if I let go of my hand, she's going to fall. Yeah, somebody's going to say animal abuse there. Okay, so, you know, when she's going to fall, but the question is she falling freely or is she not falling freely? Okay, that's the question that we need to ask. So, for example, anything that falls, okay, anything that falls, we should ask ourselves whether they're going to fall freely or not. Okay, so, okay, so she's out of the picture, so that's just a mukadimah lah. Okay, so fall freely, okay, the question that we need to ask is, fall freely from what? Okay, and the answer to that is, we are falling free from other forces. Okay, that means there's only something, there's only one thing that is pulling the object down. So for example, I had Hope just now was my dog, and then when I let her go, if she was really falling freely, she will only be falling because of one force that's acting on her. Okay, and how do you know? Okay, how do you know that something is falling freely? Okay, so I'm going to show two objects. Okay, so these are my dog's toys. Okay, I'm not sure if you can see it. Okay, fine. So I'm going to put them at the same level. Okay, and when I drop these two, sorry, I'm going to drop it like this. So when I drop these two, okay, I find that, and later you can see it, actually they're dropping at the same time. Okay, they're dropping at the same time, which means one thing. Okay, if they fall down at the same time, means they are falling with the same acceleration. Okay, and if you watched the video yesterday, we know that the acceleration we're talking about is called the gravitational acceleration. Okay, and the value of gravitational acceleration is the average value lah. Okay, of course it depends on where you are. I think where we are, the Barisan Khatulistiwa, okay, the gravitational acceleration is 9.81 meters per second squared. Okay, if you read your textbook and if you also watch the video, you'll find that in other places, for example, if you're further away from the equator, kalau kau jauh daripada Khatulistiwa, let's say North Pole, okay, the value of gravitational acceleration is slightly different, okay, which is 9.78 meters per second squared. Okay, this is somewhere at the North Pole. Okay, 9.78. But for all intents and purposes, untuk tujuan pembelajaran kita, okay, we will use this one as 9.81 meters per second. Okay, that's the first thing. So the next one I'm going to show you is from your textbook. If you have your textbook, you can open. If not, you can always look at this screen, which I'm about to show you. Okay, so as you can see here, okay, the definition of free fall is like this. Okay, an object experiences free fall if the motion of the object is affected only by the gravitational force. Okay, I'm just going to leave this as it is because nanti kamu akan belajar, you will learn about forces in another subtopic. Okay, this implies a free falling object does not experience the action of other forces, okay, such as air resistance or friction. This one comes into play when we study in the later subtopic. Dalam subtopic yang berikutnya, I think about 2.6 and onwards, okay, we will talk about air resistance and friction. But for now, kita anggap semua benda yang jatuh, okay, dia akan jatuh dengan gravitational force only. Okay, for our lesson today lah. Okay, for our lesson today. In real life, it's very different. Okay, in real life, it's very different. If you look at the next page, okay, in real life, this is what will happen. Okay, in real life, this is what will happen. Okay, you will see that the feather will fall slower. Okay, than the ball bearing, bola yang kecil lah. Okay, so this is because Okay, this is due to other forces such as air resistance. Okay, and in our real world, it's about the same. If you have two objects, okay, if you have two objects that have about the same weight or the same mass, okay, they will probably fall at the same time. Okay, but in our example just now in the textbook we saw, one is feather. Feather is very light, and it is worse because kalau kau lepaskan bulu ayam bahkan, dia akan pergi ke sini lah, ke sana lah, okay, and it will fall much slower. As opposed to a ball bearing, okay, bola besi ya, kalau dia jatuh dia akan just jatuh strut macam tu saja terus. Okay, because there's less air friction now. Okay, so I just want to introduce this to you. That when something falls, okay, in our world, okay, di dalam dunia kita, when something falls, okay, there is, of course, this one we call the gravitational force. Okay, we call it F gravitational. Okay, but at the same time, there is this force that is going upwards. Okay, yang ke arah atas. Okay, which we can call this as air resistance. Okay, air resistance is rintangan udara. We experience air resistance every day. If you have ever sat on a motorcycle before and you're going forward, okay, you feel all this wind coming at your face. Nobody, I've never met anybody that sits on a motorcycle and then dia tidak rasa pun angin di muka dia. That's probably alien. Okay, if you feel the wind on your face, that wind is called air resistance. Okay, and we are always going against air resistance because there is air. Asal ada udara, there will be air resistance. Okay, so in order for something to fall really freely, okay, bebas daripada air resistance, there's only one situation in which that can happen. Okay, is if this object, okay, falls in a vacuum. Okay, somebody watched the video yesterday and then asked me, what does falling in a vacuum mean? Mean I have to fall inside a vacuum cleaner? No, please. Vacuum cleaner is a peralatan rumah. Okay, vacuum is a place where there is no air. Okay, so in our world, because we have the atmosphere, right? So we are definitely not living in a vacuum. Okay, because there's air all around us. Okay, unless you're an alien, you cannot feel the air. But if everybody can feel the air, we are not in a vacuum. Which is why the situation I show you just now, if there's a feather and there's a ball bearing, the feather will take a longer time to fall because much air resistance against the feather. Okay, but generally, if you watch the video, there were two objects, right? There was a watermelon and I think it's called a cantaloupe atau honeydew kayak itu. Okay, but basically, but since the two of them, walaupun dia punya size berbeza, okay, but the two of them are about the same. Yes, thank you. Good question. Hold on, Chung asked me a very interesting question. Okay, two of them are about the same mass. Okay, about the same weight, hampir sama lah. Which is why in the video you saw that they were falling both at the same time. Okay, so in order for us to really see the big difference, it has to be something very different like in the textbook. One is a feather, which is super light, and one is a ball bearing, which compared, kalau dibandingkan dengan itu bulu ayam, okay, the ball bearing jauh lebih berat. Okay, kalau dia hampir-hampir sama berat, bahkan it will fall almost at the same time. Okay, just like the two dog toys. Okay, okay, just like the two dog toys that I have here. Okay, they are both about the same mass. Okay, hampir sama dia punya berat. If I let go of both of them, they will probably fall at the same time. Okay, for those of you who are in 4SA, this is part of your video assignment. Okay, you need to show me a situation where, okay, so it's a good idea to look for objects at home and see if you can find two objects that are of different mass. Okay, another one would be, okay, if I want to show a very big difference, it will be this bottle of shampoo, okay, and this cloth. So the difference is very big. If I drop this, okay, I will most likely get this one drop first and then tumpah semua lah. So I'm not dropping this lah. Okay, so this one will probably drop first and then this one will follow later. Okay, because ini ada lebih banyak rintangan udara. Ini terus ciu begitu saja, sikit saja rintangan udara yang terkena. Okay, but generally, okay, generally in our world, okay, nothing is free fall because we have air all around us. Okay, so free fall can only happen, okay, inside a vacuum. Again, not a vacuum cleaner. Okay, inside a vacuum is a place where there is no air. Okay, tiada udara di dalam. Okay, and if you look at the textbook, okay, if you look at the textbook, you will see this video, okay, that I'm showing to you right here. This is a video of an object falling in normal condition and in a vacuum. I suggest that you open this QR code later and you watch this, and then you can see the difference. In the vacuum, whether dia ringan atau whether dia berat, it will fall at the same time. Okay, and this is what we call free fall. Okay, let me repeat. Free fall is when an object experiences only gravitational force, no air resistance. Okay, no air resistance, no friction. Ini kita akan bincang lebih di dalam 2.6. Okay, so when an object experiences free fall, they will always fall at the same time. Okay, cuma in our world, if we find that if the object is about the same, mass. Okay, if the object is about the same mass, it will probably fall at the same time. We will talk about this another day. This is a discussion for another day lah. But it's very obvious if the okay, it's very obvious if the weight is very different. Okay, somebody asked me a question. What are the examples of a vacuum? Okay, the best thing about it, where do we know in our known knowledge of the universe? Okay, where is a place where there is no air? No air means there's nothing that we can breathe. Sorry, I cannot like raise hand. Okay, stomach also got air. Kau pernah kentut ke ini? Okay, stomach also got air. Okay, so definitely not in the stomach. The stomach is not a vacuum. Okay, unless you have a bottomless stomach lah, yang makan tapi tidak pandai kenyang. That's a different story. Okay, all right, thank you. Dina responded. The one place that we know that has no air at all and is a vacuum is in space. Which is why the video that you will watch and the video that I posted yesterday, kalau orang itu jatuhkan dua benda on the moon, both things will fall at the same time because space is a vacuum. There's no air in space. Okay, and in space di angkasa lepas, semua objek akan jatuh bebas. Okay, because there's only gravity pulling at it. Okay, so the definition for free fall is very important. Once we understand what is the word free, okay, it's bebas, not free percuma tau. Hello, this is not like saya bagi mas percuma, bukan. Okay, it's free fall, it's bebas daripada any other forces, only gravitational force. Okay, there's another question that came. Can we achieve vacuum on Earth? Can. Okay, watch the video in the textbook, and they will show you how to make a vacuum on Earth. Basically, a vacuum is a place where there's no air. Okay, and you can actually achieve about 95 to 98% of it if, okay, let's say you take a plastic bag. I don't have a plastic bag, sorry. You take a plastic bag and then you can seal off everything, and then you put a vacuum cleaner at the mouth of the plastic bag. You suck out all the air. Okay, you suck out all the air. When you suck out all the air, then there's no more air left. Kalau no more air left means inside the plastic bag is a vacuum already. Okay, but plastic bag, if you suck out all the air, it becomes kempes lah. Okay, let's say, okay, so this is my snack Tupperware. Okay, so let's say my snack Tupperware. If I really want to vacuum this, okay, I will put all this on, I will cover it, okay, then I will find a hole somewhere and I'll put my vacuum cleaner here. Then I will suck out all the air. Okay, when I suck out all the air, there's no more air in here, so inside this one will become a vacuum. Okay, but it's very hard to achieve this 100% lah, because sometimes you suck out all the air, then bila kamu keluarkan itu vacuum punya mulut kan, terus ada udara masuk sikit lah. That's normal. Okay. If you've ever done vacuum packing, let's say kau pack makanan makan, if you've ever done the vacuum packing, that's how we try to create vacuum. It is possible to achieve 100% vacuum, but usually in normal cases it's about 95 to 98% vacuum. Okay, thank you for the question. Okay, so the next thing that I want to talk about, any question about the meaning of free fall? Okay, free fall is jatuh bebas. Bebas dari apa? Bebas dari daya-daya lain. Free from any other force except for the force of gravity. So something is free falling if it is only falling by the force of gravity. Okay, all right. I'm going to continue on to the next part. Okay. So the next part of this is determining the value of gravitational acceleration. Just now I mentioned that gravitational acceleration is 9.81. Okay, 9.81 on our Earth lah. Okay, I'm going to skip this section for a while because I'll talk about this towards the end of the class. We're going to talk about this experiment, but this is more specifically for 4SA. Although I told Cikgu Hee and Cikgu Fiona, stop drawing on my board, please. Stop annotating, people. Okay, so I'm going to talk about this much later. Okay, in this one. Okay, so as I was saying just now, okay, 9.7. Oh, sorry, 9.78 is more for us. 9.83 is a bit further. Okay, but we average it out to be 9.81. Okay, I want to talk about these problems related to free falling objects. Okay, those of you who watched the video, okay, sorry, there's another question. Where does gravity cease to exist? Gravity ceases to exist where there is, when the force is not strong enough. Okay, for example, on Earth, there's gravity because gravity comes from the center of the Earth. On the Moon, okay, on the Moon, there's also gravity, but it's less pull because the Moon is much smaller. Okay, this is a good question now. Where does gravity cease to exist? But I will answer that in chapter 3. Okay, this is a chapter 3 question. I just want you to know that where there is a mass, there will always be gravity. Okay, this is a very important truth that we will learn much later. Okay, thank you for the question. Okay, so I'm going to talk about this, which is this one. Okay, sorry, there's another question. Sir, I don't really get the concept because if all objects, regardless of their mass, fall at the same rate, then how come the shampoo will land on the ground first? Because it's heavier. Okay, this is a good question. Let me repeat to you once again. I don't really get the concept because if all objects, regardless of their mass, fall at the same rate in a vacuum, okay, in a vacuum, they fall at the same rate. Okay, then how come the shampoo will land on the ground first? Because it's heavier. You need to go and watch the video. Okay, the video that is in the textbook. Okay, you will see two different objects, and in the vacuum, they fall at the same rate. They fall at the same rate, they fall at the same time, they reach the ground at the same time, even though one is superbly heavier than the other. Okay? Because that's what it means to be pulled by only gravity. Okay? Regardless of the mass, fall at the same rate. Okay? Watch the video and then we will come back to this question a bit later. All right. So, I want to talk about these 4 equations. Saya tidak tahu macam mana kalau kelas-kelas yang lain lah. Tetapi for those of you who watched the video yesterday, you will notice that the guy uses the 4 equations that we've studied before. Okay, these are the 4 kinematic equations. Okay, final velocity equals to initial velocity plus acceleration times time. Final velocity squared equals to initial velocity squared plus 2 times acceleration times displacement. Okay, which is this one. Then displacement equals to initial velocity plus half acceleration times time squared. And then the last one is displacement equals to initial velocity plus final velocity over 2 times t. Okay, for the students who are not from 4SA, okay, I told my students that you can actually use these equations, okay, as long as you know what are the values are in. But for those of you who studied using the textbook, okay, the textbook, VF is also known as V. Okay, VI, initial velocity, is known as U plus AT. Okay, this is the first one that you probably have there. Okay. Secondly, VF again is final velocity. So V squared equals to U squared plus 2A. And instead of D for displacement, the book uses S. Okay, V squared equals to U squared plus 2AS. Sorry, I'm going to B. And then this one will be S equals to UT plus half AT squared. Okay, and last of all, okay, this one there's 2 versions, okay, but either one is the same. You can either use S equals to, if I follow this, it will be U plus V over 2 times T. Some books will give you half U plus V times T. Okay, dua pun betul, okay, doesn't really matter. So, for those of you who are not in 4SA, don't be confused. This is not a new formula. You have studied this before in 2.1. Okay, 2.1, these are the formulas that we introduced to you. It's called the kinematic equations, except that now we are going to look at the kinematic equations when we talk about the gravitational acceleration. Gravitational acceleration is 9.81 meters per second square. Okay. Selama ini ya, in 2.1, kamu hanya membincangkan pergerakan ke depan dan ke belakang. This is the part where we use this one to talk about things that are falling. Okay, for example, if I have a pen, okay, and then I fall, I want to know how much is the velocity, contohnya. I want to know how much is the acceleration. Okay, the acceleration is definitely 9.81. Okay, so whenever we're talking about things in free fall, remember this one very important thing. Anything that is falling, the acceleration is 9.81, okay, meters per second square. The value of the acceleration is 9.81 meters per second square. Secondly, for our purposes of discussion, okay, I want you to remember that movement upwards is positive and movement downwards is negative. Okay, movement upwards is positive, movement downwards is negative, which means that since our acceleration is always downwards, okay, because dia selalu jatuh ke bumi, okay, so our acceleration must take a value of negative because it's going downwards. And this one cannot change. Even if, let's say, okay, let's say for example, if I throw this up and comes down now, okay, let me show you again, throwing up and coming down now, even as the pen is going up, okay, the acceleration is still downwards. It's still negative. Okay? Set this in your brain so that when we do the calculation later, it will make sense. Okay, I repeat, even if the object is going up, wow, look, the object is going up, okay, the acceleration is going down. Okay, but of course, if the object is dropping, kalau object itu tengah jatuh, then everything is negative because going down is negative. Okay, hold on to these two principles. Number one, the value of A, okay, for a situation where something is falling is always negative, is always 9.81 meters per second square. Secondly, the direction that we want to discuss in our discussions, all our discussions, we set, okay, kita tetapkan bahawa going down is negative, going up is positive. Okay, for those of you who were in my class last time, we already said this, when an object is going to the right, we always talk to the right is positive. And if it is going to the left, it is negative. Okay, so we do the same thing for up and down. Up is positive, down is negative. Okay? All right? Okay, so I want to introduce you to another handout. Okay, so we're going to be discussing this couple of questions. Yeah, we're going to be discussing this couple of questions and we're going to see how to answer this, okay, in a while. I did not post this. Okay? Oh, no. Sorry. Not this one. Sorry, my mistake. Okay, we're going to talk about this handout first. Okay? This one. Okay. I just want to check, are we all looking at the same thing? Are we all looking at the practice problems 2.3? Okay, sir, M over S2 and MS negative 2 same car. Okay, hold on now. Yes, the ball is dropping now. Somebody asked me this question, and stop annotating on mine, please. Okay, somebody asked me this question now. M over S squared, is it the same or not as MS negative 2? The answer is yes, it is the same thing. Okay, but for us in Malaysia, in physics, and generally all physicists around the world, we prefer to use this. Okay, it's the same thing. Okay, actually, if you think about it in terms of mathematics, it's the same thing, but we prefer to use this as a standard unit. Just like velocity, it is acceleration. Kalau velocity, the unit for velocity actually is ms negative 1, otherwise known as meters per second. Okay, same thing. Okay. Okay. M2 over S2. Okay, here deviate sudah, but M2 over S2 is not different because this is M squared. Okay, this one will be, kalau saya tulis dalam bentuk ada negatif ini, this will be M2S negative 2. This is a unit for something else, which we're not going to talk about today. Okay, I don't want to confuse people, so we're just going to focus on this. Guys, this and this is the same thing. Okay, don't be confused. It's okay. All right. So, okay, let's take a look once again at the question that we're going to do some. Okay. So, a ball is dropped from rest. Okay, the word from rest, okay, is very important. The word from rest, I just want to check, can you see my video or are you only seeing the screen? Can somebody respond, please? Can you see the video or are you only seeing the screen that I'm showing you? What is yes? Yes is the screen or yes the video also you can see. You can see my face. Okay, you can see both. Okay, I hope it's the same for everybody. All right. Okay, can see both. All right, good, good, good. Okay. Stop annotating on my paper. Tell you oh dear, saya tiada, siapa tiada? Valerie, saya tidak nampak apa. Oh dear, people, please. Oh man. Okay. I'm gonna stop here for a while just so that I can fix this annotation part. My goodness, so I also don't know what. Okay, let's try this again, people. Okay, ball is dropped from rest. Okay, I want you to note that if there is a word from rest, okay, if there's a word from rest, the answer is not no. Okay, if there's answer from rest, okay, it means that the initial velocity, okay, or the u, depending on which symbol you use, okay, equals to 0 meters per second. Okay, this is a very important meaning for us to understand. If I'm dropping something from rest, we've learned this already. Rest means the thing is not moving. If I'm dropping something, means when I let it go, okay, the initial velocity, the starting velocity has to be 0. Just like if the car is starting from rest. When the car starts to move, the initial velocity has to be 0. Okay, because the car is not moving at first. Okay, so that's a very important hidden information lah, okay, that is given there. So an object is dropped from rest. The question is, how fast is the ball going after 3 seconds? Okay, so let's take into consideration. Okay, wait a minute. And then the second one is how far has the ball fallen in 2 seconds? So 3 seconds. I like to use coconut tree because coconut tree is always very fun. Okay. So you have a coconut tree, and then the coconut decides to fall. Okay, for this one. So coconut tree falling, when it falls for 3 seconds. Okay, the initial velocity is 0 because it is at rest at first. Okay, and because it is falling, okay, there is an acceleration with a value of negative 9.81 meters per second squared. Remember, negative sebab memang acceleration is always downwards. Doesn't matter whether the object naik atau object turun, acceleration for gravity, okay, is always going downwards. So the question is, sorry, what's the question again? How fast is the ball going after 3 seconds? How fast? Okay, means the final velocity. Okay, final velocity, which is v after 3 seconds. Okay, look at the situation given. I'm giving you UTA and I want to find v. So the only formula that we can use for this is v equals to u plus at. Okay, v is what we want to find. U is equals to 0 plus negative 9.81 times 3. Okay, acceleration is negative 9.81. Time is 3 seconds because kita mau tahu. Soalan minta 3 saat. So when you calculate this, you will get, okay, negative 9.81 times 3, you will get negative 29.43 meters per second. Okay? Which makes sense because the object is moving downwards. So the negative okay, means that the object is moving downwards with a velocity of 29.43 meters per second. Okay, so I just want to remind you all that the negative sign for velocity only tells you the direction. Okay, bukan dia punya odometer kereta kan melimpasi kosong dan berputar ke belakang, not like that. Okay, it's just going in the negative direction, which for us, negative means downwards. Okay, downwards. All right. The second question, which is over here, is how far has the ball fallen in 3 seconds? Okay, when you see the words how far means we're talking about the displacement. Okay, whoever is writing this is a real coconut. Okay, so how far, okay, why ms negative 1? Because the unit for velocity is always ms negative 1. Okay, somebody is asking me in this one. Okay, so, okay. Okay, so why ms negative 1? Because the value, the unit for velocity is meters per second. Okay, we covered this in 2.1. Okay, so question B is how far has this object been falling? Okay, how far means I want to know what is the displacement. Okay, displacement is given by the letter S. Okay, let's take a look again at the information given. Okay, I know what is U, I know what is T, I know what is A, and I'm looking for S. If you look at the 4 equations, okay, which I hope you have copied down somewhere, you find that the only suitable formula that we can use is S equals to UT plus half A squared. Okay. So in order for me to find S, U is 0, T is 3, plus half. A again is negative. Don't worry about the negative, bring it in, and then T is 3 squared. Okay, don't worry about the negative sign for the acceleration, just bring it in. Okay, 0 times 3 is 0, and then this will be minus. Okay, I'm going to use my calculator to count this. Half times 9.81 times 3 squared is 44.145. 44.145. So my final answer is negative 44.145 meters. Okay, which is 44.145 meters to the down. Sorry, this is very bad English lah. Okay, but it's to the down lah. Okay, ke arah bawah. That means from the starting point until here, okay, it's about 44.145 meters. Okay, if you think about it, a 44 meter coconut tree is very high. Okay, if it is a coconut tree lah. Sir, can we use d initial velocity plus final velocity over 2t? Yes, you can use another formula if you want. Okay, can we say to the ground? To the ground cannot, because I don't know how high the coconut tree actually is. Okay, guys, you can actually message everyone in public now because I turn it on to public already. Can downwards be used? What is downward? Yeah lah, fine. Ayo. We got a lot of grammar Nazis in this form 4. Fine. 44.145 meters downwards. Okay, also can. Michelle, your question. Yes, thank you, grammar Nazi. Okay. Okay, I hope this is clear. Don't worry if I'm going too fast. When I put this up on YouTube later, you can rewind and you can recopy it all. Okay, but I'm trying to cover as much as I can in 2 hours, so that so that I can finish teaching whatever I'm supposed to teach. Okay, let's look at the second question in the handout. For those of you who have the handout, you can refer to it. For those of you who don't have, you can look at this. Okay, platform diving in the Olympic Games takes place at 2 heights, either at 5 meters or 10 meters. Okay, if anyone is an Olympic fan or if anyone is a swimmer or diver here, you will know what this situation is talking about. So the question is, what is the velocity of a diver entering the water from each platform if he steps off the platform initially? Okay, so we're going to talk about this first. That's the question. Okay, so the question now is, what is the velocity of that? So you have this situation now. Okay, okay, let's say this is this is the pool. Okay, it's an interesting pool, and so you have 2 heights. Okay, one is, sorry for my horrendous drawing. This is 5 meters. Okay, and another one is, oh sorry, all the way down here. Okay, it's 5 meters, and then all the way up here. Okay, oh sorry. Okay, it's 10 meters. Okay, that's what it says. So you have 2 divers over here. Okay, And if you look at the question says, how much time, what is the velocity of a diver entering the water from each platform if he steps off the platform initially? Means he's not doing any like wow macam itu, okay? It's just wow, macam tu lah. Okay, just there and waiting 1, 2, 3, and then he's just gonna step it off. Okay, which means that in these both cases, okay, the u is again equals to 0 meters per second squared. There is no initial velocity. He's just stepping off. Okay, but the question is asking when this guy enters here, okay, what is the final velocity? When this guy enters here, what is the final velocity? Okay, think about it logically. If you have a guy with 5 meters and a guy with 10 meters, okay, even without calculating, kalau tidak mengira langsung lah, kamu fikir sejenak. Okay, siapa yang akan lebih laju? Who will be faster? Okay, entering the water. Logically, it will be 10 meters lah, so dia higher. He has more ground to cover, and dia lebih banyak. The acceleration is the same, okay, but because the height difference, he will probably enter the water faster. Okay, so let's prove this by using calculation. Okay, let's talk about the 5-meter guy. Okay, the guy at 5 meters. So u equals to 0 meters per second. Okay, our displacement, okay, is 5 meters. Okay, is there any other information that we can find from here? Okay, I'm going to stop here for a while, and I just want to mention that continuing from this, so what is the information that we have that is given now is also, once again, A is equals to negative 9.81 meters per second squared. Okay, sorry, one more other thing that we need to mention is that since he is going downwards from his initial position, the displacement is also negative 5 meters because he's going downwards. Okay, so we want to find what is V. Okay, and there's only one formula that we can use for this, which is V squared equals to U squared plus 2AS. Okay, V squared equals to US plus 2AS. So V squared we don't know, but U we know. 0 squared plus 2 times negative 9.81 times negative 5. Okay, remember the displacement is negative because he's going downwards. Okay, so when we calculate this, we will get 2 times 9.81 times 5, okay, which is 98.1. Okay, so V squared equals to 98.1, and if we square root the V, okay, we can find the V squared equals to, yeah. Okay, square root of 98.1 is 9.9. 9.9 meters per second. So Uma, Zoom got problem. Sorry, if you have Zoom has problem, then you can always watch the video on YouTube later. Okay. Yeah, but thank you for informing me. The person that informed me. Okay. Okay, so the V is 9.9 meters per second. But again, remember that this guy is going downwards. Okay, so actually the value of his velocity is negative 9.9 meters per second because he is going downwards. Okay, so the direction of the velocity also is very important. The velocity, the displacement, the acceleration, all same direction. So since you're going downwards, it must be negative. Okay. So what about the guy from 10 meters? We already said that 10 meters must be faster than the 9 meters one, the 5 meters one. So we are expecting an answer that is bigger than 9.9. Okay, let's try and see. V squared equals to U squared plus 2AS. V squared equals to 0 squared plus 2 times negative 9.81. This time, no longer multiply by negative 5, but multiply by negative 10 because it's going downwards. Okay, so V squared equals to, calculating 20 times 9.81 is 196.2. Okay, 196.2, and you will find that V equals to the square root of 196.2, which is equals to 14. Okay, 14.007 meters per second. And again, because it's going downwards, okay, it's going negative. And therefore, we've proven that the guy from 10 meters will have a bigger velocity downwards, okay, than the 5 meters. Okay, hold on, the video call is lagging. Yeah, I know. Is everything okay now? Are you guys still, am I still stuck? Like, am I still stuck? Am I still stuck? Oh, still stuck. Okay, let's wait for it to stabilize. In the meantime, while we wait for it to stabilize, you can copy down this one. For those of you who are from 4SC and 4ST, I will pass the worksheet to your teacher. Okay, then nanti dia akan forward to di tempat kamu lah. Lagging, sir, and blur. Okay, am I blurry? Yeah, sorry. Okay, so Chong Xian En. Okay, all good. Okay, good to know. Okay, so again, I repeat, if for those of you who want the worksheet for this, I will give it to your teachers and then they will pass it to you. Okay, but for now, I'm just going to answer it. If you want, you can just copy it first. Sir, why dear negative 10? Negative 10 minus 1. This one. Because he is falling 10 meters downwards. Dia punya displacement ke bawah, so the displacement must be negative. Because kita sudah tetapkan bahawa going down is negative, going up is positive. Okay? And acceleration is always going down because kamu melawan gravity. You're either following gravity or you're going against gravity. Okay? All right. Is everyone doing okay so far? We are about 45 minutes into this. So I hope. Why velocity is negative? Because it's going downwards. Okay, it's going downwards. Okay. Okay, maybe I should explain this now, but this is mathematical. So those of you who don't want to follow this conversation is fine. Let's say V equals to 4. Okay. Sorry, V squared equals to 4. This is mathematics. Okay. So V is actually equals to square root of 4. And in mathematics, you should know by now that the square root of 4 got two answers one actually. The calculator will only give you one answer, which is positive 2. But actually, there's also negative 2. Either one of these will give you the answer 4. Think about this. Positive 2 squared, 4. Negative 2 squared is also 4. So there are two possibilities for a square root. Either a positive number or a negative number. So I can say, betul, dalam calculator, bila kau tekan ini kan, 196.2 square root, okay, you will get positive 14.007. Correct. The calculator is not wrong. Your calculator is not Rosa. You don't have to change calculator. You don't have to change battery. But you have to turn on your brains and remember that anything square root now can have two possible answers. And we need to choose which answer is suitable for our situation. Our situation is the guy is going downwards. So his velocity has to be negative. Okay, because he's going downwards. So guys, don't just depend on the calculator as your brains, but we also have to turn on our brains whenever we do calculation questions. Okay, that way we train our logical thinking. Okay, then that way you be logical thinkers. Public service announcement for the day. Okay, thank you for the question, the person that asked it. Okay, I'm going to continue on to the next question. Okay, please don't annotate on this. Okay, leave your fingers alone. Okay, a model rocket is launched straight upward. Okay, read through the question first, people. Okay, a model rocket is launched straight upward. I wonder whether you guys did this rocket experiment when you were in Form 3. Did you guys do it? Like, you know, when you were in Form 3, like most people I know that when they went through Form 3, I'm sure they play it, the pumping, and then wow, and then everybody gets splashed with water, like wow, it's super fun. Okay, so a model rocket is launched straight upward at 58.8 meters per second. Now this situation is very different. Question is, how long does it take? Okay, 58.8 meters per second. Question is, how long does it take to reach its peak height? And then after that, what is the total time of the flight of the model rocket? What is the peak height? Okay. All right. So I'm going to start by asking this. Okay, let's imagine the situation once again. Okay, so you have this rocket. Oh no, this is not a rocket. You have this rocket. Okay. Yeah, it looks like a fish that's swimming upwards. Doesn't matter. Okay. Have we discussed 2B? Sorry, did I not discuss 2B? How much time does it take the diver? Oh yeah, my goodness. Oh, no. Sorry. Okay. Can I come back to this question later? Okay, let me answer this. Let me answer this rocket one first. Okay, because I'm very sorry, I forgot about 2B. But I'm going to answer this rocket one first. Okay. So this rocket is moving upwards, and they say that when it is launching at 58.8 meters per second. Okay. Now, if you think about the situation, it is starting at 58.8 meters per second, which means that this is the initial velocity. And since it is going upwards, this is a positive value. Okay, that's the first piece of information you have. Okay. Secondly, you are also given, okay, think about this. And this one was discussed in the video. If you don't remember, then you discuss it now. Whenever you throw something up to the ground, whenever you throw something up, okay, I'm going to go as far away as I can. Sorry, there's this wall here. Okay, whenever you throw something up, okay, after it goes up, then it will come down. Sorry, after it goes up, it will come down. Now, in order for it to go up and come down, it needs to slow down, stop, and then come down again. I repeat, it needs to, when I throw something up, okay, it needs to go up, stop for a while, then it has to come down. Now, because it is stopping for a while up here, okay, just like the rocket, okay, it's going to go up, and then it's going to slow down. It's going to slow down, people. It's going to slow down until the velocity reaches 0 meters per second, because it has to stop for a while. Okay, going up, stop for a while, baru dia boleh turun. Okay, because if it doesn't stop, it's just going to go on and on and on. Okay, so go up, stop for a while, and then come back. So this is a hidden information that we need to think. Okay, whenever you throw something up, maybe tonight when you're in the shower or when you're eating, you throw the chicken bone up and down. Okay, remember, okay, stop and then come down. Okay, stop, come down. Stop, come down. Stop, come down. Like that. Okay, so on top here, the maximum height is when it stops. Okay, so from the time it starts until the time it stops. Okay, I'm going to draw this ugly rocket here. Okay, from here to here, okay, this is the displacement. Based on this, we have a lot of information here. Okay, so I'm going to answer the first question again. The first question states that, how long does it take for the rocket to reach its peak height? Which means that we are asking, how long does it take to go from here until the peak height, okay, where it stops? Because after that, it's going to come down. Okay, so I have U equals to positive 58.8 meters per second. I have my V equals to 0 meters per second. Because at peak height, pada ketinggian tertinggi, dia mesti berhenti seketika. Go up, stop, and then come down. Must. Anything you drop into the air must stop for a while before it comes down. Okay? And then, of course, since we are going up and down, we are talking about acceleration. And acceleration is always on the opposite direction, minus 9.81 meters per second. And we are looking for time. Okay. Look at your 4 kinematic equations. There's only one formula that we can use for this, which is V equals to U plus AT. Okay, I want to find time. So V is 0. U is positive 58.8 plus A is negative 9.81, and then we want to find time. Okay, so I'm going to move this across. So 9.81 T equals to 58.8, and T equals to 58.8. So 58.8 divided by 9.81 is 48.99. 48.99 seconds. So it takes about 50 seconds, okay, for this rocket to reach its peak height before it comes down. Okay, so this is the answer for question A. Okay, 48.99 seconds for it to be dari launching sampai ke ketinggian yang tertinggi. At the peak height, after that, you know it's going to fall. Bukan bahagi. Bahagilah 58. Am I not right? 58.8 divided by 9.81. Oh, sorry. My bad. Thank you very much for correcting me. T equals to 5.99. T equals to 6 seconds. Is this correct, everybody? Did you get 6 or am I the only one that's like sorts out? 58.8 divided by 9.81. Is that correct? 6, huh? Okay, thank you for the response. So, okay, sorry, my bad just now. So it takes this rocket 6 seconds, okay, to go from here all the way to here before it stops. Okay, so imagine the situation as we go into question B. Question B says, what is the total time of the flight of the model rocket? Okay, total time of flight, think about it. Total time of flight means how? The rocket is going to go up, and after it stops there, where is it going to go? It's obviously going to go down. Okay, so if it is free falling, okay, this is where all this free fall comes into place. If it is free falling, means the amount of time it takes to go up is also the same amount of time it takes to come down. So to go up is 6 seconds, coming down is also 6 seconds. So for B, the total time is 6 times 2, which is 12 seconds. Okay, it takes 6 seconds to go up, 6 seconds to go down. In the case of free fall, okay, if it is free falling. Okay? Of course, in reality, it's different lah. Okay, pada keadaan sebenar, it will probably take a lot longer for it to come down. But we're only discussing free fall. Okay, free fall means there's no other force except for acceleration. Okay, so I just want you to know that. All right, let's go to question C. Question C says that what is the peak height, okay, of the rocket from the ground? Okay, which means now we want to know, this guy is traveling for 6 seconds. What is the displacement over here? The peak height. Okay, we want to know what is the displacement. Sorry, I'm going to change this into S. Okay, let's once again review the information that we have. We have 58.8 meters per second. Okay, we have 0 meters per second as the final velocity. And we have the acceleration, negative 9.81, going downwards. Okay, I want to know what is the displacement. If you look at the 4 kinematic equations, there's only one that fits all these 4, which is V squared sama dengan U squared plus 2AS. We want to find S. Okay, we want to find S. So V is 0 equals to U is 58.8 squared plus 2 times negative 9.81 times S. Okay, so I'm going to calculate this 58.8 squared, which will give you 3457.44. 3457.44 equals to 0. I'm going to calculate this 2. 9.81 times 2 is 19.62x. Okay, then it's a matter of pindah-pindah, and you can get the S lah. Okay, so I'm going to move this across. So 19.62S equals to 3457.44. If I make a calculation mistake, please tell me. Okay, because once again, I'm only human. Okay, so sorry, I got no more space anymore. This time I get a bigger whiteboard. So basically, the peak height is the displacement. Correct, very good. Okay, the displacement in the upward direction. Okay, so S equals to 3457.44 over 19.62. Okay, and you'll get 3457.44. Okay, divide 19.62. You should get about 176. 176.22. Okay, meters. Okay. Which means for 6 seconds, it's traveling about 176.22 meters. Okay, so the video is stuck. Yeah, I'm sorry, I can't really do much about the video being stuck. But I hope it's only stuck for you. Is it stuck for everyone, or are you guys okay? Sorry if the video is stuck. Don't worry, you can always watch the replay on my YouTube channel. Okay, and you can always subscribe to my YouTube channel. Thanks. Okay, mau jadi influencer lah konon. Okay, so for 6 seconds, this rocket is traveling 176 meters. Okay, and it is positive because it's going upwards. Okay, so all the calculations make sense. Okay, as long as we follow it strictly. Okay, I'm going to go back into the question that we answered just now, which I missed, which was what question was that? Was it B or C? Question B, okay, question B. Okay, how much time does it take the diver to reach the water from each platform? Okay, so I'm going to rub this off again. I'm going to rub this off, and I'm going to need to ask you once again for the values that we had. Okay, for the 5 meters one, what was the final velocity? And what about the 10 meters? Can somebody please type it out? For the 5 meters, what is the final velocity? Waiting for people to type. What was the final velocity for the 5 meters per second? Negative 9.9. Thank you. How about the 10 meters one? Negative 14. Thank you. Negative 14.007. Thank you. Okay. Meters per second. So we want to know how long it took, okay, for them. So let's put up all the information. U equals to 0 meters per second. We have different displacements. Okay, one is negative 5. This one is s equals to negative 5. This is s equals to negative 10. We want to find the time. Okay, sorry, I'm going to change it to t. Okay, so take a look at the information. We have s, u, v, and we want to find t. So if we look at all the 4 equations that we had earlier, okay, there's, sorry, Lester, what do you see wrong? Oh, 14.007. Okay, fine. Yeah, sorry, I'm writing. Okay, so there's only one formula that fits in this case, which is S equals to U plus V over 2 times E. Okay. Now, before I continue, I just want to make another public service announcement here, in which there are actually 4 equations, and I would really recommend that you memorize all the 4 equations. Jangan mengharap kepada formula yang diberi dalam peperiksaan sahaja, because memorizing these formulas will help you a lot. Okay, there's only 4 formulas in it. If you can remember the words to a Korean song, I'm sure you can remember 4 formulas. It's just letters and numbers. Okay, how difficult can it be? Okay, so please memorize this so that your life will be much easier. Okay, so I want to find t. I'm going to start with the 5 meters first. Okay, 5 meters is negative 5 equals to u plus negative 9.9 over 2. Sorry, u is 0. Okay, times t. Okay, I'm going to solve this first. Negative 5 equals to 9.9 divided by 2. Okay, this is negative 4.95 t. Okay, so t equals to 5 divided by 4.95, 1.01 seconds. Okay, 1.01 seconds. So the 5 meters guy, okay, the 5 meters guy, he only took 1 second before he fell into the water. Okay, so obviously the 10 meters one is going to take a longer time than the 1 meter. Okay, let's prove it mathematically. Okay, so same thing, negative 10, we're using the same formula, people. Okay, negative 10 equals to 0 plus negative 14.007 over 2 times t. Okay, so negative 10 equals to 14.07 divided by 2. 7.0035. 7.0035 negative, sorry. T. So t equals to 1.43. Okay, 1.43 seconds. Okay, which makes sense, lah. Okay, to us, we only look at it as 1 second, but in the real world, 0.01 and 0.43 seconds is a very big difference. Okay, so for us, it's like, 1 second juga, sama juga. Okay, but it makes a big difference. Okay, because this will ask the question, how come they're not falling at the same time? Okay, how come they're taking different times to fall? But that's another question for another day. Okay, I just want to show you how to do the calculation for today. Okay, so the time now is 3:13. Okay, I would like to ask your permission to take a break. Okay, because I'm losing my voice. So let's take a break. Okay, maybe if you want to go to the toilet, if you want to go to the canteen, if there's a canteen near your house, okay, you can go to the canteen and take a drink. Okay, drink some water. I'll see you back in 2 minutes. Okay. People, even if you're chatting, please a little bit more this one lah, jangan terlampau. Oh dear. Okay, so everyone, we're going to answer this one last question. Okay, which is this. Okay, in a class experiment, to determine information about freefall acceleration, a watermelon and a pumpkin are each set to fall from the back of the stands of your football stadium. Okay, so the question is A, if the watermelon and the pumpkin are both dropped at the same time, which one will hit the ground first? Okay, I'm sure that by now you can tell me the answer, okay, or at least you can defend what your answer is. So I'm going to leave this with you. For 4SA students, this is a part of your homework. When we open school, I want to hear this answer from you. Okay, which one do you think will hit the ground first? The watermelon or the pumpkin? Okay, if you think that it's both, okay, some people are answering me privately, you say it's both, I want you to explain to me why it is both. If you think that the watermelon is going to fall first, if you think that the watermelon is going to fall first, then you tell me why the watermelon falls first. If you think the pumpkin is going to fall first, then why is the pumpkin falling first? Okay? All right, second question. If the watermelon is thrown downward with an initial speed of 10 meters per second and the pumpkin is dropped, which one will hit the ground first? This is very logical. Okay, if I don't drop it at the same time, this is very logical. Okay. Okay, so I'm going to leave this again. I'm sure you can figure this out for yourself. You think logically, you will know the answer. Okay, if you throw something first or if you just let it go, which one will fall first? Okay, it is most likely, okay, figure out the answer for yourself. Okay, C, if it takes the watermelon 1 second to reach the ground, okay, when it is thrown downward, okay, at 10 meters per second, how tall are the stands? Okay, let's answer this. So you have this watermelon that is being thrown. Okay, it is not being dropped. If it is being dropped, okay, remember, kalau dia kena drop, means the U equals to 0. But since it is being thrown, okay, I'm throwing it. So since I'm throwing it and they already give me the Chung, you're probably correct, okay, whoever this Chung is, it is thrown at 10 meters per second, which means that this is my initial velocity, okay, and I'm going downwards, so it's negative 10 meters per second, okay. Secondly, is that I still have my gravitational acceleration. Even if I'm throwing something, gravitational acceleration is still there, which is going to be negative 9.81 meters per second squared. Okay, and because I'm reaching the ground, okay, this is okay, the watermelon already pecah belah lah. Okay, so I'm going to get V equals to 0. The question is, how tall is the football stadium? Okay, I'm talking about S. So look, I have S, A, U, and V. I'm only going to use one formula, which is the only one left, which is V squared equals to U squared plus 2AX. Okay, V squared is 0 squared equals to negative 10 squared plus 2, negative 9.81 S. Okay, so this is 0 equals to 100 minus, oh dear, 9.81 times 2 is 19.62S. I'm going to move this across here. 19.62S equals to 100. So S equals to 100 divided by 19.62 is about 5.0. Sorry, 5.1. Okay, 5.1 meters. Okay, so the watermelon was falling for about 5.1 meters. Okay. But the purpose of this exercise is to show you that no matter what, if I'm throwing something, that's the initial velocity. If I'm dropping something, or if something drops, like the coconut fell just now, okay, the initial velocity is 0. Okay? And since it's going to reach the ground, okay, so the V will be 0. Okay. So, then the last question. The last question is, how long does it take the pumpkin to reach the ground? Okay, if it is dropped from this height. So the height is 5.1 meters. Okay, but okay, so we want to know now the time. Okay, so this is different story already. Pumpkin was not thrown, it was dropped. So since it was dropped, the U is 0 meters per second. Okay, and I want to know how long is the time. Okay, the time taken. Okay, I have S equals to 5.1 meters. Okay, and I want to know how long is the time. I'm sorry, I need to check something. Oh, okay. Right. Sorry, people, I'm going to backtrack because I just realized that I made a mistake in the question before this. Okay, I'm very, very sorry for this. But I'm going to backtrack again. So the watermelon was thrown. The watermelon was thrown at 10 meters per second. Sorry, the watermelon was thrown at 10 meters per second negative. Okay, and actually they give you the time is 1 second. My mistake, my mistake, sorry, because I assumed that the V is 0. Actually, the V is not 0. Okay, so I'm very sorry for this. I'm going to rub this off and try again. Okay, so I'm given a time, I'm given the acceleration. The initial velocity is negative 10. I want to find S. Okay, how much is this one before it hits the ground? Okay, so the only formula is S equals to UT plus half AT squared. Okay, which is one of the formulas that you have learned. So S equals to negative 10 times 1 second, because the question gives 1 second, plus half A is negative 9.81 times 1 square. Sorry, 1 square. Okay, so this will be S equals to negative 10 minus 4.905. Half times negative 9.81 times 1 squared will give you negative 4.905. Okay, so my answer will be negative 14.905 meters. Okay. So that means the height of the stadium, Okay, it's about 14 meters. Okay, 14.9 meters. Okay, so that brings us to the last question, which was question D. Okay, if I'm, how much time? Okay, if my distance is now negative 14.905 meters, how much time? Okay, do I need if I'm dropping the pumpkin? This is now pumpkin. Just now was watermelon. Okay, so we use the same formula again because S, U, A, and T. This time we are finding for T. We're no longer finding for S. Okay, so this was the watermelon situation. Now pumpkin. Pumpkin, S is negative 14.905. Okay, equals to U is 0 times T plus half times acceleration is negative 9.81 T squared. Okay, I want to find T. Okay, I want to find T. Okay. Okay. So negative 14.905 goes to 0 times T will be 0, so this will be moved. So 9.81 divided by 2 will be negative 4.905 T squared. Move the 4.905 over negative 14.905 divide by negative 4.905 equals to T squared. We will get 4.905. We will get 3.03. Okay, T squared equals to 3.038 T squared, no? 3.0387. So T will be the square root of this. Okay, square root of this, I will get about 1.74 seconds. Okay, so why the length of the stem is negative? Okay, somebody asked me a question. I don't know who this is, but thank you for the question. Why is it that the height is negative? Remember, because the thing is falling. Okay, the displacement is negative, correct? Okay, fine. If I'm going to technically put this, once I get this calculation, okay, then I will add another sentence. Okay, the height of the stadium is 14.905 meters. Okay, then that makes sense. Okay, because height again is a scalar quantity, so the direction doesn't matter. But when we are counting, because originally the watermelon is falling from up, going down, so its displacement is negative 14.905 meters downwards from the original position. So the height is 14.905 meters. That's a very good question from Kiyoshi. Thank you very much. Okay. So question D, to find the time, we use the same formula, except that now you must remember the displacement takes into effect. Okay, so negative, then we count, kita akan dapat T sama dengan 1.74 seconds. Okay. A big part of this subtopic is the calculation. Okay, because in 2.1 we learned the 4 equations, and now but in 2.1 we already talked about kiri kanan saja. Now in 2.3 we are talking about up and down. Okay, the important thing to remember about up and down movements is that the acceleration is always the same value. It is always negative 9.81 meters per second squared because it is moving downwards. Okay? Once you remember this, then it becomes very easy. Okay, so it's out of the question, but why is acceleration dependent? Okay, acceleration is independent of mass. I'm going to answer this when we go into chapter 3. Okay, it's a very long topic, and I probably won't have enough time to talk about the assignments. Okay, if I'm going to be talking about this. But thank you for the question. It's a good question also, but I will answer this in a minute. Thank you. Okay, so this is it. Okay, this is all for the class. For those of you who are not in 4SA, if you want to continue to stay on, you can always stay on. But I'm now going to talk about the experiment. Actually, I think all 3 classes kamu pun akan buat ini eksperimen ini sebenarnya. Cuma I want to give this briefing, okay, to everyone in 4SA first lah. Okay, but you're welcome to stay. Not a problem at all. Okay, so to those of you who are in 4SA, I want you to please take a look once again at the Google Classroom. Okay, I want to remind you that, okay, today is Freefall. Okay, we're studying this Freefall. Okay, and we've done these two, the video and also the practice problem. Okay, completed. Okay, so now what I want you to do is there is a Flipgrid assignment. Okay, there is a Kahoot quiz which you can access from this classwork. Okay, if you feel confident enough to answer this Kahoot quiz, then go ahead and answer the Kahoot quiz. Please remember that if you're going to answer the Kahoot quiz, once kamu sudah habis, okay, please remember to make sure that you turn in the assignment. Okay, don't kasih tinggal sajalah. Okay, we've talked about this for a very long time. Don't forget to turn in your assignment. Okay, but if you want to take your time, if you want to answer it in before 1st of April, it's fine. Okay, the Flipgrid assignment is in the Flipgrid itself. I can show it to you in a while, but this is the one I want to talk about. Okay, click on the link to the website on the video, how to find acceleration due to gravity using tracker. So when you click this link, okay, you will be brought here, and okay, so there's this website, everything. This yada yada is not important, but this is the one that's important. Okay, we have learned how to use tracker. Now we're going to use tracker and this experimental setup to find the value of gravitational acceleration. Okay, we want to see that if we use tracker, are we going to get the 9.81 value? Okay, this is the point of our experiment. Okay, but the problem is in your textbook, okay, if you look at your textbook, okay, our textbook, dia punya, hold on, okay, our textbook, dia punya eksperimen kan bukan pakai tracker, dia punya eksperimen pakai photogate, okay, which we don't have in our school, okay, very sadly lah, but it's okay. If what I want you to do is I want you to prepare the experimental report. Just follow the title, aim, apparatus, but the apparatus will probably change. Okay, watch the video. Watch the video and think for yourself what is the apparatus needed. Okay, obviously you need a laptop lah. Okay, we will use the same grouping as we did the last time. So we will need a laptop. We will probably need a camera, okay, a phone camera, because the last time we used tracker for that. But take a look at the video and then you can add the apparatus in here. Jangan salin ini bulat-bulat lah, so kita tidak pakai ini. Kita pakai tracker. Okay, so even the procedure also is a little bit different. Okay, take a look at the procedure in the video. Okay, the video dia ada procedure dia di sana, bahkan try to don't copy this at all because this one has nothing to do with us. Okay, I want you to only prepare the report until procedure sahaja. So it will only probably take 1 page. Even the procedure also, I think it's only about five steps maximum. Okay, so prepare the experiment report. When we finish our movement control order, this is the first thing we will do. Okay, this is the first thing we do. Okay, now I open for any questions. Salin the report in. No, we are not supposed to salin this report now, sister, because we are not using photogate. We are using tracker. Okay, we're using the tracker app. So even yang apparatus pun kena ubah. Even this lukisan also kita kena ubah. Okay, so this is a little bit of a challenge. I know it's a little bit of a challenge, but okay, in order to help you, this is what I'll do. Maybe, okay, some of you yang before SA, what you can do is you can draft out the procedure first. Okay, then post it up on the Telegram group and let me take a look at it. Kalau saya rasa lulus, then everybody can salin from the same person. Okay, please don't everybody depend on one person only. Try to do it yourself and then put it in the Telegram group. Okay, then kalau saya rasa lulus, then everybody can copy from that person. Okay, but the idea is to get you to think of your own langkah-langkah. Okay, so try to do that. But again, in order for you to know what is going to happen, you need to watch the video first. Okay, you have to watch the video to understand how to do the experiment. Dan lepas itu kamu rangka ayat sendiri and put it in a Telegram group. Snap a photo of your procedure, put it in a Telegram group, and then we will work things out as we go along. So mau ikut dalam bit tu kayak apparatus and the drawing? Yes, follow that as closely as you can. We will probably do that. We may adjust it a little bit, but probably not much. Kita akan ikut juga dalam video. Sebab senang. The video makes really using tracker helps us to find the gravitational acceleration much easier. So can I use Microsoft Words to type it out? Okay, I need to know who this Chong Sian Eun is, but yes, you can use Microsoft to type it out and then you can send it to me in a Telegram. I can help you to check. But sorry, are you my student now? I mean, do I teach you in 4SA? Because I don't remember anybody by this name though. Is there anybody named Chong in our class? Ada Chung lah, saya tahu, tapi ada Chong lah. Okay, no mind, no response. Quick. It's okay. So that's the first thing. Okay. Then the second thing is I'm going back to the Google Classroom again. Okay, the Google Classroom. So the Kahoot quiz, I hope every one of you is familiar with this. Okay, the Flipgrid assignment. I want to talk about this Flipgrid assignment. Okay, sorry. I'm going to, hold on, let me log in first. Okay, for those of you who are in my class, this Flipgrid assignment, you can actually start after this class. Okay, pergi cari lah kopi anjing ke kopi apa kan, then drop the anjing or whatever. No, please, no, sorry, no animal abuse. So I want to ask about apa yang mau buat di rumah itu. I mean yang rakam-rakam. Okay, I'm going to talk about this soon. Hold on, Umar. Okay. So. Okay, first of all, for those of you who are not in the Flipgrid, okay, this is our class Flipgrid. The code is Q5687. Okay, and these are the two assignments that you need to complete sebelum habis perintah kawalan pergerakan. Okay, but I'm only going to talk about this, okay, which is the Freefall di sana. So you need to make a video. This is an individual assignment, bukan group assignment. Okay, satu orang satu. So make a video showing how two objects with very different masses fall in the air. Very different means dia mesti satu yang sangat berat dan satu yang sangat ringan. Please don't drop a glass cup. Okay, don't drop a glass cup. Saya tidak mau dipersalahkan. Kenapa saya punya anak pergi pecahkan saya punya kaca-kaca di rumah? Janganlah. Okay, drop something that's very heavy and very light together. Just show me how they drop very different. Okay, and okay, mau buang anak buah is not my problem now. Okay, then after that, from that video, explain to me why they will reach at different times. Okay, I showed it to you just now. One is a shampoo bottle and one is a cloth. They will both reach at different times. So tell me why they reach at different times. Number 3, explain the difference in the observation if those two objects fell in a vacuum. Okay, and number 4, state in which situation were the objects free falling and state what a free fall is. So actually, only number 1 yang kami kena tunjukkan. Okay, you choose 2 things with different masses, you drop it for me. Okay, and then you see whether they drop at the same time. They should not be dropping at the same time, especially if they're 2 very different masses. Kalau kamu pilih benda yang sama dia punya mass, for example, 2 pens, okay, it's about the same mass. It's going to be very difficult for you. Okay, so choose things that have very different masses. Okay, so choose things that have two very different masses, drop them. Okay, and then number 2, number 3, number 4 is not show me the video, just explain to me. Okay, so after you drop, explain to me. Answer question number 2, answer question number 3, answer question number 4. I'm going to show you again the 3 questions after you do the video. Okay, after you do the video, tell me why they reach at different times. Okay, number 3, tell me what will happen if I do the same thing but in a vacuum instead of in our air. And the 4th one, state one situation, in which situation lah. Okay, which situation, is it the one in the air or in the vacuum? Which situation were they free falling? And then tell me what is the meaning of free fall. Okay, the reason for this video assignment is to purposely make you, say out, because I've been doing the talking for the past 2 hours, and so I want you to purposely say out and tell me what you understand by free fall. Yes, explain in the video. Okay, so the limit for the video is 5 minutes, but actually, I think 2 minutes is enough. Okay, but maybe some of you want to make a very extravagant video, come on, lebih-lebih, go ahead. Okay, you have all 5 minutes to complete the video. But this video all must be complete in this one. Okay, some of you have already started to try. What is the code for free call Flipgrid? There's no free call Flipgrid. Okay, somebody said I tried pen and A4 paper, but macam same juga. Actually, it's not the same. Okay, it's not the same. it's a bit difficult, lah. I know it's a bit difficult, but try to, experiment, try to choose objects with very different masses, okay, and try to drop it, see if you can get them to fall at different times. Okay, but the idea is to, whatever that we've learned, I want you to understand the concept of free fall, okay, which is free from what. Okay, so I think that's about all from me for today. Thank you very much for coming. If you have any questions, I will answer any questions we have. We have about 15 more minutes, but those of you who have no questions, you can leave. I noticed quite a lot of them have left already. I'm left with the few people from SA, so it's fine. I'm going to stop the